Hello everybody and welcome to section 3.5. This is proving lines parallel. So this section is about giving you some traits about angles in a diagram, and if these traits are true then we can definitely know that the lines are parallel. So let's start with postulate 3.4. If two lines in a plane are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. The abbreviation here is if corresponding angles are congruent, then the lines are parallel. So if we know that 1 is congruent to 5, and if 2 is congruent to 6, and if 3 is congruent to 7, and if 4 is congruent to 8, and all those sets are congruent, then we know for sure that line M is parallel to line N. 3.5 is the parallel postulate. If a given line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. Okay, so basically, if you have a line and some other point not on the line, then they're saying that there's exactly one line that goes through that point that is going to be parallel to the other line. So the red and the white and the green line are definitely parallel, and there's only one line that passes through that point that is parallel. That's all that postulate says. Okay, moving on to next one. 3.5, Theorem 3.5. If two lines in a plane are cut by a transversal so that a pair of alternate exterior angles is congruent, then the two lines are parallel. So here's the abbreviation. If alternate exterior angles are congruent, then the lines are parallel. So if we know that angle 1 is congruent to angle 8, or if angle 2 is congruent to angle 7, then we know here in this picture that line M and N are parallel. 3.6. If two lines in a plane are cut by transversal so that a pair of consecutive interior angles is supplementary, then the lines are said to be parallel. The abbreviation is if consecutive interior angles are supplementary, then lines are parallel. Just like that is our abbreviation. So here, if it is given that 3 and 5 add up to 180 degrees, and if we know that angle 4 and 6, if they add up to 180 degrees, then we know that line M is parallel to line N. Okay, last one here. Okay, section 3.7, theorem for 3.7. If two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are parallel. Here's our abbreviation. If alternate interior angles are congruent, then the lines are parallel. So in this picture here, if they tell you that angle 3 is congruent to angle 6, or if angle 4 is congruent to angle 5, then we know that M and N are parallel. Let's point those angles out. Here's 3 and 6. They're going to tell you that those are congruent. 4 and 5, we're going to tell you that those are congruent. Then we know M and N are parallel. And the last one, in a plane, if two lines are perpendicular to the same line, then they are parallel. And the abbreviation is pretty much the same thing. If two lines are perpendicular to the same line, then the lines are parallel. So if they tell you that line L is perpendicular to line M, and line L is also perpendicular to line N, then we know for sure that M is parallel to line N.